Hello everyone, my name is Erica Covarrubias, and together with my partner Turner Lee, we have prepared this presentation for ESS1, Learning Progression for Earth and Space Science. A learning progression shows how students understand over time. Instead of acquiring facts each year, students expand on their existing knowledge. In this presentation, you'll observe how students progress from making basic observations in the early grades to employing evidence and scientific reasoning to explain Earth and science phenomena. Slide 2 shows NGSS evidence statement for grade 1, which outlines what students should understand and demonstrate by year's end. These statements also emphasize the science and engineering practices, core ideas, cross-cutting concepts that underpin the performance expectations. On slide 3, we show how performance expectations are applied in the classroom. So before starting first grade, students are familiar with the sky, through everyday experiences. They understand that there is a day and a night, having seen the sun during daytime and the moon at night. However, they have not yet learned that these observations follow predictable patterns. In first grade, students start thinking like scientists by observing carefully. The key question for this lesson is, what patterns do we see in the sky? The performance expectation 1, ESS1-1, asks students to use observations of the sun, moon, and stars to describe patterns that can be predicted. So students demonstrate this expectation by observing the sky over 1 or 2 weeks, recording what they see during the day and night. They draw the sun, moon, and stars, compare observations with classmates, and collaborate on identifying predictable patterns via a shared class sky chart. For engagement, they would do a think, pair, share discussion. Students explain their observed patterns and discuss how these can be used for making predictions. In this lesson, it also connects to other content areas. Students improve their ELA skills by labeling drawings and writing sentences about their observations. In math, they can count days in lunar cycles and recognize repeating intervals. A key aspect of this learning progression is ensuring that students exit first grade with observation skills. They are able to identify patterns in nature, and these observation skills are serve as a basis for their upcoming learning in second grade. For this slide 4, it shows grade 2 evidence statement. It shifts its focus from students what they prioritize using information from various sources as evidence to explain Earth's process rather than just making observations. So the next slide 5 for grade 2's lesson. By the time students reach second grade, they have already developed the ability to observe patterns in nature from their first grade experiences. Now they enhance these observation skills by learning to use evidence to explain scientific phenomena. The essential question is, how do we know Earth changes happen at different speeds? The Performance Expectation 2 ESS1 1 asks students to use information from several sources to provide evidence that Earth events can occur either quickly or slowly. So, a lesson activity linked to grade 2 ESS1 allows students to analyze videos, images, and readings on earthquakes, volcanoes, erosions, and weathering. Working together, they categorize each event as a fast or slow earth change, support their choices with evidence, and create a class anchor chart as an engagement activity. So, students also strengthen their literacy abilities by creating evidence based expectations with sentence frames, using sentence frames. Math is incorporated through comparing various timescales, including seconds, minutes, days, years, and even thousands of years. So, compared to first grade, students have moved beyond simply recognizing patterns to use evidence to explain why changes occur on Earth. So, this foundation prepares them for higher grades where they will analyze fossils and rock layers and ultimately develop scientific arguments based on evidence.
The next slide moves on to grade 4, Fossils and Earth History. Just like the others, it has the NGSS guidelines. This one talking about identifying evidence from patterns in rock formations and fossils in rock layers to support an explanation for changes in the landscape over time. It also has the science and engineering practices, the disciplinary core ideas, and the cross-cutting concepts. The next slide explains our performance expectation for 4-ESS1-1, which is identify evidence from rock formations and fossils to support explanations of Earth's past. In 4th grade, students begin using evidence to explain how Earth has changed over time. The performance expectation focuses on using rock formations and fossils to support explanations about Earth's history. The phenomenon for this standard is finding fossils of ocean animals in rocks and on mountains. This encourages students to think about how landscapes have changed over millions of years. Students build on what they have learned in the 2nd grade about fast and slow Earth changes by examining fossils and rock layers as evidence. During the activity, the students investigate fossils and rock images and use claim evidence and reasoning, or CER, format to explain what the evidence tells them about Earth's past. This helps students strengthen their scientific reasoning and communication. Just like students analyze images of rocks and layers with evidence over millions of years, just like the previous was thousands of years. So there is that big age gap or time gap that not skipped, but you need to know the thousands before you go to the millions. The next one is grade 5, Stars and Distance. Just like the previous, there is the NGSS standards and guidelines, which for this one support an argument that differences in the apparent brightness of the sun compared to other stars is due to their relative distances from the Earth. The science and engineering practices talk about analyzing and interpreting data, and the universe and its stars and its disciplinary core ideas, with the sun being a star that appears larger and brighter than the other stars because of it being closer, and the stars range greatly in their distance from the sun. The next slide talks about, in 5th grade, how students expand their understanding of Earth and space by learning why the sun appears brighter than other stars. The performance expectation asks students to support an argument that differences in the apparent brightness of the sun and stars are due to the relative distance from the Earth. The students build on their previous experience using evidence by conducting a flashlight investigation that models how distance affects brightness. They then use their observation to explain why the sun looks brighter even though it is also a star. This lesson encourages students to develop evidence-based arguments while also applying the concepts of scale and distance in space. There are also the ELA connections, which students will use evidence from their flashlight investigation to write a scientific argument explaining why the sun appears brighter than the other stars. The technology, the star distance simulation or the space visualization tools, which there are a ton online for students to use, and the math connection is comparing relative distances using the scaled models. The next slide is a progression ladder, which this learning progression shows how students, how their understanding develops across the ESS1 standard from 1st through 5th grade. In 1st grade, the students begin by observing and identifying patterns in the sky, such as the movement of the sun and the phases of the moon. In 2nd grade, they build on those observation skills by using evidence to compare fast and slow changes on Earth's surface. By 4th grade, students use fossils and rock formations to explain how Earth has changed over long periods of time. Finally, in 5th grade, the students apply evidence to support scientific arguments about why the sun and stars appear to have different brightness levels. Each grade level builds on the previous one, helping students develop stronger observation, reasoning, and evidence-based thinking skills. Thank you.